Welcome back. In the last episode, we started to learn about software models, and we covered functional model, which was represented by the use case diagram. In today's video, we'll learn about the object model and how the object model can help us understand the structure of a system. So let's get started. The object model describes the structural system in terms of object, their attributes, association, and the operations that can be performed by the object itself. A class diagram is used to represent the object model for a system. Now let's see, what does a class diagram consist of? A class diagram primarily consists of classes that represent the system. Remember that a class represents a blueprint or a template for the object and can be used to create instances of the class. Each of these objects will have certain attributes. These attributes are nothing but the properties of the object. Further, these classes define a set of functions that are supported by the object. The structural relationships of an object with another type of object is generically called as an association. The association can be of different types, for example, inheritance, composition, and aggregation. But we will cover all of these topics in detail in subsequent videos. But for now, we would simply define the relationship between objects generically as association. Let's go through a simplified class diagram in order to learn more about the object model. In our example system, the concept app, we have identified the following classes. User. User is a class that represents a generic user. The user has properties like name, the details about the user, their location. The user class supports a number of functions. For example, the function like register that creates an account for the user in a system when they register via our concert app. Set a profile. These functions allow the users to create their profile for other users to view and follow them. We have two specific classes of user in a system. The first is the fan, and the second one is artist. Now the fan represents the end user who wants to attend the concerts. The fan class has property-like preferences that allows them to specify the kind of music events that they would like to attend. The fan class supports functions like buy ticket, which allows the fan to purchase a ticket for a concert, and the functions like view concert that allows the fan to view the live concert stream for which they have purchased the tickets earlier. Artist. The class artist represents the user who creates events, performs at the concert, and wants to sell concert tickets to their fans. Artist has properties like genre, which specifies the genre of the music that is played by the artist. This will help us recommend events to the fans by matching artist genre with the fans' music preferences. The artist class provides functions like the publish event that allows the artist to create and publish music events, broadcast event, the function that allows the artist to start broadcasting of live event to the music fans. Finally, the generate report that allows the artist to generate event stats and other engagement reports when the event has ended. We have some other important classes in our system. For example, the event class. The instance of the event class represents an event, and this is the event that is created by the artist for the fans to attend. The event class has properties like name and store the details of the event. The event object stores a reference to the artist that created this event and defines an association relationship between these two classes. Further, the event class has properties that store the event timings and the ticket fee associated with the event. The event class further provides functions like start broadcast and end broadcast to start and stop broadcasting of the live event. The ticket class represents a ticket for an event. The ticket has properties like the user, the ticket that belongs to, the event is associated with. So you can see the ticket class has relationships or associations with other classes, namely user and event. Further, the ticket stores the cost that was paid by the user. The ticket class supports functions like purchase ticket that creates a ticket when the user wants to purchase the ticket for an event. It also supports function like redeem ticket that marks the ticket redeemed when the user watches the event live. The class diagram shows the relationship between those various classes. This is shown by the lines that connect these various classes. Here, both the fan and the artist class represent a specific class or user. And in our model, they extend from the generic user class. This kind of relationship is called as inheritance, which is a specific form of association relationship. This association is represented by the is a relationship. For example, the fan is a user. An artist is a user. An artist can have one or more events that they have published, which is represented again by 1:n relationship. One or more tickets will be created for an event, which is indicated by 1:n relationship. The direction in which we define and read this relationship matters and is very important. The relationship between event and ticket should be defined as 1:n and not n:1. As for one event, we can have multiple tickets, but a ticket cannot be associated to more than one event. A user can purchase one or more tickets, which is indicated by 1:n relationship. The class diagram helps us understand the various objects that make up the system. It also provides a very good overview of the relationship between each of the objects and provides a good structural overview of the objects that exist in our system. This concludes the video on object model, and in the next video we will continue with the dynamic model. Thank you.